Good evening, everyone, and welcome to the Canberra AWS user group for September 2020. I'd like to begin by acknowledging the traditional custodians of the land we're presenting from, the Ngunnawal tribe, and pay my respect to their elders past and present. This evening, we're going to take you through the usual run-through of AWS news and what's been happening in the world this month. We'll talk a little bit about where you can find online training, some of the white paper releases that have come out this month, and then into our main presentation, the introduction to AWS for Research IT, being presented by Raisa Hashem from my team here at AWS. Now, the first thing I want to announce in terms of what's new this month is we've got a YouTube channel. I've finally gotten around to pulling all the recordings together from our live broadcast sessions since we began in March this year and put them all somewhere that you nice people can go out and watch at your heart's content. Now, you see the URL there. Don't try to type that. It's probably going to be garbage. But the thing is, apparently, YouTube won't give me a custom URL until I've got 100 subscribers. So my ask to you people is to please go and subscribe to our YouTube channel. We'll take the recordings each month and continue to put them up there so that if you want to go back and rewatch any of our sessions, you'll have a full history of them there. But for the time being, if you go and search for Canberra AWS user group on YouTube, you'll find our channel and our content. Now, in terms of what's been happening with AWS this month, by the numbers, there have been 189 releases so far, which for those of you who love graphs like I do, looks a little bit like this. I say so far because there's still one more day, like the releases that come through tonight for the US will be the last day of the month, and that number will probably change slightly, but it gives you a bit of an idea of where we're at. Now, my top 10 that I wanted to call out for this month, things worth knowing about. First of all is we've announced the general availability of AWS BottleRocket. So what BottleRocket is it's an open source operating system based on Linux that we've built and prepared specifically to run container-based workloads. So it's been optimized and trimmed down to give you only what you need to effectively run containers. BottleRocket went into preview a few months ago, and we've had a lot of feedback from customers to help us fine-tune what this GA release looks like. But it's now generally available and supported and ready for you to go out and use running your container workloads right now. My second update is that CloudFront has made an announcement to support real-time logs. So if you're using CloudFront at the moment as your content distribution network, really great to make sure your users can get to your content in a really low latency way, good for caching content. The logs that you get from CloudFront previously would ship in a manner where you would get them usually up to an hour later, sometimes up to 24 hours at the top end of that documentation. So now with the real-time logs, we've got the ability to connect a Kinesis data stream to your CloudFront distribution, so that way you can get those access logs in real time. So if you need to analyze trends or look for particular patterns as they're happening, now you've got the ability to do so with Kinesis and CloudFront. Next, Amazon Lex has launched support for Australian English. So Lex, for those of you who haven't come across it, is essentially our chatbot interaction service. So previously it had support for a few other locales of English. Now we have support for Australian English, which means when I'm interacting with my chatbots, either with voice or with text, anything that's registered in that Australian locale will be able to be detected more easily and let you have a more localized experience for your users running within Australia. So, Bonza, g'day. Thanks, Lex. Next up, Systems Manager. AWS Systems Manager, specifically the Patch Manager component, now has the ability to support on-demand patching with 2 mouse clicks. So what this does is it essentially gives you a nice, easy-to-see spot in the console where you can say, I want to go into patches and then either start a scan and report against breaches of a patch baseline, or you can say scan and install, and it will simply go out and start looking for patches on demand that aren't installed on your instances that should be. This really is starting to make the whole, how do I patch an entire fleet of servers and make sure I'm compliant? Systems Manager is something that is making this so much easier, and now you can do this on demand with 2 mouse clicks. Next up, AWS Step Functions has added support for AWS X-Ray. So Step Functions, if you're not familiar with it, is essentially our state manager workflow service. So I can use it to define a process, and so string together Lambda functions or reads and writes from Dynamo, or there's a bunch of other things that you can integrate into it. But with things like conditional logic, doing things in parallel, those sorts of things. It now has support for X-ray, which means it's really easy for me to get a visual service map of what step functions is calling out to and then what it's calling on those functions' behalf. And I can really get a nice view of the performance and availability and reliability of my app with X-ray, and just by turning on that configuration within step functions. So again, if you've looked at X-ray for performance management and visibility of your apps, now you can bring your step functions-based apps into X-ray. Next, AWS and Docker have extended collaboration to launch some new features for Docker Desktop. So earlier this year, we made the announcement that AWS and Docker were partnering in terms of enabling better integration of features and services between AWS and Docker, and specifically what's going on in the Docker Desktop product. What we've done this month is we've added support for a couple of different things. Firstly, it's a lot easier to integrate CloudWatch logs into your Docker solutions so that I can have a nice consistent logging experience from my container workloads. The second is that from Docker Desktop, I can now refer to secrets that are stored in AWS Secrets Manager. So if I'm running containers and I need to debug them and test with dynamic credentials to an RDS instance, for example, I can integrate those Secrets Managers based credentials into my Docker workflows without having to use a specific call through the AWS CLI or anything like that to retrieve those credentials. So this means that we've got some really nice integration going on between AWS and Docker there, and I look forward to seeing where else that's going to go in future. All right, my last four. Next is the usability improvements for the AWS Management Console have gone out this month. So if you're a regular user of AWS, you might have noticed that the services menu and the header and the footer of the page look a little bit different. So the main changes that have been made here is that the new menu is more sort of resizable for different device form factors. Plus, it's also in most supported browsers able to be navigated in full with a keyboard. So previously, if you wanted to add shortcuts, for example, you needed to remember what the icons for each of those services were, or put the text in there, which took up more space on the screen. Now you've got more room for favorites, so that's up from 5 to 15, and you can set up those favorites with a keyboard. You no longer require a mouse to drag and drop those. So it's a more accessible version of that AWS console and specifically the services menu. So that's available now. Amazon Detective has introduced new IAM role session analysis. So Detective is a really great tool for being able to help troubleshoot and identify the root cause of security issues in your AWS account. It refers to information from CloudTrail, from Security Hub, from GuardDuty, and helps you analyze and sort of get to those root causes quicker. What's been added this month is the ability to look at IAM sessions that are being happening and what your users are doing. So for example, I could ask Detective a question in the form of what federated IAM roles were making calls related to a specific security finding. So that makes it really easy to work backwards from a security finding to figure out what federated user was logging in to be able to get to that thing and cause me a security problem. There's a bunch more scenarios attached to this as well that make it really easy to, rather than dig through the logs yourself to find out, Detective will do the legwork for you here and help you get to conclusions quicker to secure your environments fast. Second last one, we're introducing the AWS Cost Anomaly Detection Preview. So this is built into the Cost Explorer, and one of the things that customers want to stay on top of is what's their spend on AWS like. And if somebody accidentally turns some services on and you're running up a bill that you're not expecting to, you want to find out about that sooner rather than later. What this anomaly detection feature does is it uses machine learning to identify patterns in your spending that look unusual, so we can flag you about it early and you can go and review it and have a look at what's going on before you get to the bill shock at the end of the month, if that's what you've inadvertently stepped into. So this is a really great example of how customers have asked us to use the technology in AWS to help them with their outcomes and help manage their cost. So we really do want to make sure that you don't get a big ugly bill at the end of the month and that you're paying for what you use and what you expect to be running. And that's what this preview is all about. So if you're interested in managing your costs, I encourage you to go in and check that one out. And lastly, more one for our New Zealand friends, but Amazon CloudFront has launched a couple of new points of presence, and one of those is in New Zealand finally. So this is our first CloudFront pop in New Zealand, and that's going to help make sure that New Zealand customers of applications and platforms running on AWS and using CloudFront get a really good experience being able to connect to that point of presence and come over the AWS network back into the Sydney region. So big win for our brethren over the ditch there. Now, as always, I would typically be referring to what classes are going on in Canberra right now, but again, in-person stuff is probably still not the wisest thing to be doing, but there is still a ton of online training going on, and I really want to make sure that everybody knows where to find that. So if you head to aws.training and search for any of those courses that are running virtually, you can sign up to any of those running in a time zone that suits you and still get the same content that you would normally get in a classroom, but delivered in a remote scenario. White papers that have been released this month. So there was a bunch of new ones. In fact, I think there was only one updated one this month, a lot of new white papers. Things like Amazon Honeycode and the shared responsibility model there. So if you're looking at Honeycode for building no-code solutions, now you can get a bit more of a feel about what that shared responsibility model means applied specifically to the Honeycode software. The architecture guidance for migrating load balancers to AWS is in there. There's a new hybrid connectivity white paper. So if you're looking at having that hybrid options between your on-prem environments and AWS, this new white paper can help you sort of understand what's going on there. A bunch of other ones as well, cloud native data visualization, moving to managed file systems, lots of good material as always. So if you're trying to figure out and learn something about AWS, the white papers library is always a great place to start. All right, so before I hand over to Raisa, the last couple of things that I like to call out is what do you want to hear? You know, we always love hearing from people who are attending our user group and interested in knowing more about AWS. If there's a particular topic you want to hear about, please send us a message through Meetup. We will do our best to find a presenter for you. Also, if you're interested in doing a presentation, you know, one of the great things about this user group is that not every month is at the AWS show. We've had customers and partners from around Canberra and since the lockdown from even further come and present for us and tell us about the cool things they're doing with AWS. I'm actually looking to, over the next couple of months, try to put together a sort of lightning talks session. So if you've only got like 5 minutes worth of something interesting that you want to talk about, I very much so want to hear from you. So we can put together a session that's going to be a lot of small talks with people just talking about things they've been doing with the platform. So again, let us know if you're interested. Also, submit your feedback every month. Last month was an especially low turnout on that. So if, again, I see the numbers, we pay attention to them every week, because every month, because they help us make sure that we keep bringing you the content that you're interested in. So please, when you get that little notification from Meetup, go through and submit the feedback. If you're watching us and you haven't signed up through Meetup, if you head to meetup.com/AWSCBR, you'll be able to register there, get notifications about our new events, and then get notifications to submit that feedback for us. And again, we're really grateful for those of you that are doing that. And lastly, as I say all the time, friends, don't let friends miss the AWS Canberra user group. Word of mouth is our best mechanism to help grow the community, get more people around, to tell more stories about things they're doing with the platform. So if you like what you're seeing tonight, if you're watching this on Twitch or on a shiny new YouTube channel, share it, tell other people about it, because that really is something we appreciate in terms of growing this group. So on that note, I'm going to hand over to this evening's main presenter, Raisa Hashem from Amazon Web Services, and she's going to introduce us to AWS for Research IT. Raisa, would you like to kick off and introduce yourself?
Absolutely. Thank you so much for that, Brian. Hey, everyone. I'll just share my screen really quickly. Bear with me. Awesome. Thank you so much for having me. I'm Raisa Hashem. I'm a Research Specialist Solutions Architect here at AWS. I'm based out of Melbourne, so excited to be here with you, virtually. Just a little bit about me. I am a biomedical engineer in background. I've been working with cloud for probably almost 6-7 years now, but through a various set of roles and predominantly specializing in DevOps and DevOps security. I've been working a lot with our enterprise customers over the past few years around accelerating their applications and their workloads securely to deploy faster to their end users and customers. Recently I've moved into this role where now I'll be working with researchers across Australia and New Zealand, accelerating their speed to science. So very excited to be talking to you about how we can use AWS in research and essentially for research workloads. So I'll take this cue to continue on. I'm also monitoring the chat as well, so if you have any questions throughout this, let's make this as interactive as we can. Please just feel free to put your questions into, through the chat. I'll be able to answer it as we go. Awesome. So what we'll cover today is how AWS is related to research, because it's actually not about servers, it's about the science. So I'd like to take you through today around all the resources and services that we have in AWS and how essentially it's going to be helping you achieve your research outcomes faster. We'll discuss how collaboration works when you're using or doing research on AWS, and that's got a lot to do with our global infrastructure. So it actually just makes collaboration and sharing your research outcomes that much easier. Reproducibility is quite big as well in research. You want to be able to leverage the data as well as the research that's already being done and essentially work off of that rather than recreating the same data sets that's already been created before. So we'll talk about how you can achieve reproducibility in research. And we'll talk a little bit about analytics and machine learning and how that's used in research as well. And of course, security is always top of mind, how you'd be able to use the services that we have on AWS to be able to achieve security for your data as well as for your research workloads. So let's jump right in. I'll take you through a little bit of data to begin with. The most recent survey that we have, it's not so recent because it's in 2004, as you can see there on the left. But this data actually shows you full-time professors across US universities that has a total amount of time doing research. And as you can see, it's actually 18% because most of their time actually goes to administration or teaching. And a more recent study done in 2018, as you can see on the right, has similar findings across universities in Netherlands, broken down by category of professor. And as faculties become more senior, more time is actually spent on supervision and management of research than research itself. So the thing is, the time that's spent on research is actually really squeezed in, and having to spend often longer hours, longer work hours to be able to squeeze in that research. So when you're really doing that research, you want to be able to maximize the output and minimize the time you're spending on the administration of research itself. And that's basically the aim here. The aim is that on AWS, we are here to enable you to get to faster research outcomes by, again, taking away the undifferentiated heavy lifting that you might find that you're doing with your current on-premise infrastructure. So how is AWS related to research? Well, the answer comes from looking at the global infrastructure. AWS has a global reach, as we all know. Today our infrastructure spans across 77 availability zones with 24 geographic regions around the world. And these numbers continue to grow. One of the things about AWS is the global infrastructure doesn't just support Amazon. It supports millions of active customers every month and over 10,000 academic institutions around the world. And the secret to being able to support this scale is in automation, because the aim is to automate as much as possible, and this automation does not only support IT, it supports research. So imagine what it could be like scaling your research in this way to be able to achieve this global reach and scale for your research. And that's also, what we are wanting to achieve here. So the infrastructure that enables global IT systems to function smoothly can actually also help researchers as well as helping businesses and enterprises. much of what researchers do, wherever a computer is involved, can be automated. It might not be worth this for one lab to do this, but the thing is, even if you do it for a lab, you'll be able to greatly reduce your errors. But it's definitely worth to be able to share the work that other labs are doing to enable reproducibility of important results and findings, and of course on the data. This in turn advances science because knowledge can be generalized. The coded infrastructure and scientific pipelines really represents the knowledge of a graduate student, a postdoc, or a researcher. And just like we often talk about a shortage of IT expertise, there is usually a far greater, in my opinion, shortage of scientific expertise. So being able to share code, share infrastructure is shared IT talent, and being able to share scientific pipelines and infrastructure is sharing scientific expertise. And finally, we argue that the weak link in research process is usually human time. And leveraging technology helps us to save time, right? By sharing automated research workflows, research data. So, there are these ways that what you can see on the screen, these are basically the summary of the ways that AWS can help you do better research. So first and foremost, it's about science. It's not about the servers. So you get to use computers when you need them. When you need them to do the work that you need without becoming too fond of them. So not treating the servers like pets, but essentially you spin them up when you need them, you get rid of them when you're not using them anymore. And what you're able to do then is essentially manage the cost factor as well. So essentially you're not paying for what you're not using. Secondly, collaboration. So sharing and accessing large data sets across institutions. And of course that enables better research and better research outcomes. Sharing the effort, so leveraging the work done by other scientists to save time, and of course time is a big factor, and replication. So AWS provides a common platform for reproducing scientific data analysis, and we'll talk a little bit about that today. And a state-of-the-art analytical tools. So you're able to leverage tools developed by data scientists for advanced analytics and machine learning, even if you have limited access to data scientists or even if you're not one yourself. And AWS just makes that easy and accessible. And lastly, one of my favorite topics, security. So in July 2020, we announced that 92 AWS services have successfully assessed compliant with the Australian Government Information Security Registered Assessors Program. That's a mouthful, but basically IRAP, for operating workloads at the protected level. And what that means for you is that it enables you to use AWS to build a wide range of applications and services securely for the benefit of your research and of your research workloads and in your data. So pretty awesome things there. But let's talk a little bit about how we work with researchers. So the engagement starts early. So usually when the funding grant cycle starts, that's basically we identify our work with researchers, identify grants with cloud addressable components. And this can be, in the space of a few years even. So basically working with that grant cycle. And then as the research proposals and the grant take shape, we are able to help by providing you sort of proposal support. So we've got technical BDMs, technical writers, templates to accelerate the grant shaping, letters of support, and any other sort of AWS-related support documents. So we're able to help you with that process and help make that faster for you as well. And then building on AWS, so once you've actually had that whole grant proposal shaped and you're starting to do the research, we're able to essentially federate with the organization in terms of access to be able to provide you a sort of a simplified access to AWS, secure infrastructure. So IRAP, I mentioned earlier, and of course, HIPAA, there are HIPAA compliant workloads and architectures as well that obviously you're able to use for medical workloads and medical data. And training as well as webinars, right? We've got regular webinars that happen on a monthly basis for research that you're able to access to see how other researchers around the world are actually doing research on AWS. And we've got a multitude of partners who actually are deploying research solutions that you'd be able to use on AWS as well. So it really is helping you build faster, so you're not having to reproduce content yourself. You're able to leverage what already exists out there. Accelerating time to science, so basically making it data-centric and science-centric rather than, of course, compute and infrastructure-centric. And you're able to share data. So there are actually a lot of open registries where data is housed that you're able to use for repeatability of your research. And that leads to sharing. So if you go on GitHub, you'll be able to see that a lot of research code is actually shared. AWS Exchange shares data as well. There are heaps of workshops that you're able to leverage to keep learning about AWS, but more on how research is done on AWS. And of course, there are heaps of talks, articles, and blogs as well. So we continue working with researchers in this way, but obviously we'd love to hear from you. So we'd love to see how you are using AWS for research, or if there are considerations and you're wanting assistance, we'd love for you to reach out to us as well to see how we can enable you, or essentially liaise you with other researchers so you're able to do some better collaboration. And again, it's about science, it's not about servers. So what do I mean by that? Well, the idea is that we are able to help you with the broadest and deepest platform choice to enable your science, enable the science and research that you're doing on AWS. So Brian spoke a little bit about containers. Containers today are simplifying the development and management for compute, and with serverless computing further simplifying areas so that customers can go right to building applications in the cloud without needing to worry about servers or clusters. And I'm seeing that across enterprises, but of course also across a lot of our public sector customers and a lot of our research organizations and universities. Developers have the option of running their code as serverless containers with AWS Fargate or serverless functions with AWS Lambda. And our customers and organizations of all sizes have told us how compelling the benefits are of serverless computing for them. And because basically they can just, bring their code and essentially start running it straight on cloud. They don't have to worry about the resources or managing servers. And that same thing essentially applies for research. But if you do need compute, right, you're likely to come and find a virtual server or EC2 instance, obviously in the case of AWS. And there are a lot of different types of servers to choose from. So within each type, you get a smaller or larger size of virtual machines, and some have GPU accelerators, others have high RAM, still others have fast disk for heavy disk I/O, and then there's these really tiny ones that you basically don't have to pay much at all, that don't cost you much. So you really do have the option, if you are looking for compute, that you're able to choose from a really large subset of instances. And Spot is something that we see a lot of our research customers using, especially for workloads that are not tightly coupled. So, if you've got a large number of jobs that you have to run, especially from a HPC perspective, you can use EC2 Spot instances to be able to schedule those and kind of set and forget about them. And then, once that computation happens and it churns out the results for you, you're basically saving costs of up to 90% compared to the on-demand instances. So EC2 Spots are also a massive favorite that I see our researchers using. But one of the cool ones, and I guess one of the ones that I'll be talking to you a little bit about today is Parallel Cluster. So obviously a bit of an apt name because obviously it's a cluster that's running jobs and parallelly. It's an AWS supported open source cluster management tool that helps you define deploy and manage high-performance computing clusters on AWS. If any of you have used CFN Cluster in the past, Parallel Cluster is basically its improved reincarnation because it's built on the open source CFN Cluster project and enables you to quickly build a HPC compute environment in AWS. It automatically sets up the required compute resources and shared file systems. You can use AWS Parallel Cluster with a variety of batch schedulers AWS Batch is one that's obviously from AWS, but you can use other ones such as SG, Talk, or Slurm. And what I like about it is that it facilitates you to quickly start a proof of concept, right? You can get your environment set up and running very quickly, and you can get a proof of concept happening quickly. But you can actually also use it for production deployments. So you can build higher level workflows like a genomics portal that automates an entire DNA sequencing workflow on top of AWS Parallel Cluster. So yeah, it's pretty cool, I reckon. So I'll give you an example. Say that we want C5 compute nodes and we want the Slurm scheduler on the head node, and you want about 500 gigs of shared file system. And there's a script that you want to run on first boot to install some computational fluid dynamics packages and store some data from S3. So Parallel Cluster will actually take all of those configuration options and they live in a text file in Parallel Cluster, and it sends it to AWS. And 10 minutes later, it gives you the IP address of your head node, and you just escalate into that node like you would any other Linux instance. And you know, that's it. Basically, you're there in a bash cell where you have a scheduler, and you can submit jobs and run scripts and do all the things that make your life wonderful. So yeah, it's pretty cool in that way. What I'd actually love to do is I'd love to actually show you that, but let me just take you through a couple of other services. So I've mentioned AWS Batch. Basically, it's a service that makes job scheduling super easy. It dynamically provisions compute resources based on the volume and requirements of submitted jobs, and will actually plan, schedule, and execute your batch jobs across your resources. So there's no batch computing software that you have to install. You can just focus on your application and, of course, your research results. So it's pretty cool to get started with that. Of course, the storage options that are also there with the compute instances. So EBS obviously is the primary solution for durable high-performance storage for your instances. And a lot of our customers are actually using that because you know, they like the size and performance, and basically you can adjust that on the fly with no disruption to your workload at all. So it happens to be you know, quite a bit of a you know, popular choice amongst the research customers. But the other ones that are also there essentially are the file storage and, of course, object storage. So S3, I think most of us will know that S3, obviously because it's, you know, it's got 11 nines of durability, you can't compete against that. But also the low cost and reliability, you know, the reliability factor as well to be able to store your data. But the one that's been using, sort of coming up a lot as well with our research customers is FXX for Lustre. So it's built on the Lustre system, and it's meant for high performance and compute intensive workloads. And with FXX for Lustre, you can actually process hundreds of gigabytes of throughput per second, millions of IOPS, and sub-millisecond latencies. So it's natively also integrated with S3 for long-term storage, so you can store data cost-effectively in an S3 data lake, load data into Lustre for analysis, and write output back to S3, and then spin the FSX Lustre down, so you can end up saving costs significantly over the Lustre setup that you may have on-premise. So that's basically kind of the compute landscape when you're wanting to do research, and they work really nicely integrated together. And of course, you're not having to build up, you know, or manage any of the compute and infrastructure yourself. You're essentially just paying for what you're using.
Cool. Okay, so now that I've introduced you to Parallel Cluster, let's actually go through and create a Parallel Cluster ourselves and run a sample job. So yeah, why don't we actually do that together instead? So let's go ahead and into a demo. So I'm running this in a Cloud9 instance. And I'm using Cloud9 because it helps bring out consistency in the dev environment. So if I was to do it from my local machine, maybe I'll have some packages that I need, maybe I won't, but essentially Cloud9 gives me a very consistent dev environment. So if you're not familiar with Cloud9, it's a cloud ID for writing, running, and debugging code straight from the browser. It's got a rich code editor, integrated debugger, and a built-in terminal, and of course the AWS CLI is also pre-configured. So it's just super easy for running, getting up and running with Parallel Cluster, and of course a lot of researchers use it as well. Okay, so at a high level, what we'll be doing through the demo, first we'll install and configure Parallel Cluster in our Cloud9 IDE. Now, I already did this earlier, but I'll just show you that we'll just be using pip, so Python and Python package management tool pip to be able to install Cloud9, install Parallel Cluster in the Cloud9 environment. So basically, I'll go ahead and do that. Next, we'll actually create our first cluster, and then we'll submit a sample job and check what's happening in the background, and once we're done, we'll delete the cluster. So it's pretty simple. We'll keep it nice and simple today. Mainly, I just want to show you exactly how easy it is to get Parallel Cluster up and running. Okay, so now that I've installed Parallel Cluster in this environment, let's just go ahead and actually create a cluster. It's as simple as a one line, essentially. Let me just clear this out real quick. It's essentially one liner. So I can just go ahead and give me 1 second, I'll bring this up here. I will actually show you as well. So to be able to create the Parallel Cluster, we actually need to also have our configuration file. So that's basically what helps generate the Parallel Cluster as per or the settings that you've identified it. So let's actually go ahead and have a quick look at the configuration file, and then after that we'll essentially create our Parallel Cluster. So you can see the configuration file here. Maybe I'll blow this up a little bit so it's easier to see. So you can really see that, so I'm running this in Singapore region, but I'll also be running it in Sydney region, so you can see the Sydney region name there. But the key things to really notice is that I've got a head node and compute node. So my head node is going to be C4 extra large, and my compute instance is going to be the same. For HPC workloads, we usually would use C5N instances, but for our purposes, just for a demo, we'll be using C4 extra larges. We actually use a placement group to maximize the bandwidth between the instances and to reduce latency. So this packs the instances really close together inside of the placement group. So you can see there we've got the placement group, which is of a dynamic placement group, which means that the cluster will actually have 0 compute nodes when starting. So you can see it says initial queue size is 2, max queue size is 8. And that means that we're actually going to be automatically scaling our clusters or essentially our compute nodes in the cluster up and down based on what the initial and the max queue sizes are. But it is dynamic, which means that it'll actually be auto-scaling and will grow and shrink between the minimum and maximum limits based on the cluster utilization and the job queue, that you've got, essentially the backlog of job queue that you have. So that's essentially what you're identifying there. And then you can notice that we've got a GP2 Amazon EBS volume that will be attached to the head node. So I'll just go down here so you'd be able to see. And we'll actually be using Slurm as our job scheduler. So I guess, we can use a fair few different types, as I already mentioned earlier. We would be able to use SGE or AWS Batch, but I'll talk more about that soon. But for our purposes today, we'll be using Slurm. So basically, based off of this config, we essentially just identify that, okay, well, this is the cluster that I would like to create based off of this config. So let me just go ahead and say, so pcluster create HPC lab demo 2 and using the cluster config file. So I'll just get that up and running. So it's basically beginning creation. Now it does take a little bit of time to create, so I just want to show you what essentially happens in the background. So I've created one earlier, obviously. All right, so essentially what it's doing at the background is it's setting up for you a bunch of CloudFormation templates, a bunch of nested CloudFormation templates. So if we have a look at one, you'd be able to see it's creating a bunch of different resources. So I don't know if this is too easy to see, but let's see if we can do our best here. So essentially, if we just look here, you'd be able to see, so this is creating SQS and SNSs. It's also creating your master server node, your actual parallel cluster policies. So it's creating a lot of different resources that obviously work together under the hood to be able to provide you a sort of low latency throughput environment. Okay, so now that we have that up and running, basically, let me just go ahead and go into my actual node that I've set up earlier, just again for the ease of getting something up and running quickly. It does take some time to create. So this is the one that I created earlier. Essentially, this is sort of my master node that it's giving me the IP of. So you can see that my public IP and my private IP. So I've just used that to essentially log into the head node. And if I just go into my EC2 console, you'd be able to see that this is basically the master that's running. And it actually has also started to compute instances as well. But the thing is, the instance dates, so if I just do sinfo as you just saw me do that earlier, I did this earlier and it actually showed that, okay, I've got 2 instances running, but it's sitting in idle. But if I do sinfo again, it's saying that there's actually no nodes that are up and running at the moment. And that's because there's no jobs. So we haven't actually given it anything or scheduled any jobs at the moment, which means that because there's nothing in the backlog, it essentially just shrinks down. So you're not having to pay for the resources that you're not using. So it's pretty cool. So we can actually run a few more commands, and this will actually show you any queues that is as well configured, which we shouldn't find anything, but let's just type it in anyway. Yeah, so essentially you can type in sinfo or sq to be able to see what you have in terms of your nodes or in terms of your queues, and you'll notice that there's nothing there because we haven't actually set anything up. But let's actually go ahead and do a few more things and get familiar with the environment and before we actually do our schedule our first job. So lmod is a fairly standard tool that we use to dynamically change our environment. So we can actually use it to list available modules as well. So that's I'm just going to blow this up a little bit so you'd be able to see a little bit easier. And let me just clear this out so you're actually able to see a bit easier as well. Okay, so basically module AV should be able to tell us what modules are running, so we can see that these are some of the modules that we've got happening in here. And you'll actually be able to load up modules as well. So we want to be loading up Intel MPI in our environment, and we also want to be checking the path of MPI run, because that's what we'll be using today okay, so cool. So we've actually got MPI set up. So that's basically what we'll be using today to create our Hello World MPI workload. So that's good that that's running. We are also going to be you'll notice actually that there are a few volumes that are set up in the head node and that are actually mounted on the compute instance when they boot up. So you can actually check what shares are actually available using this command here. So you notice that you'll be seeing that there's both shared and home that's actually accessible by all nodes, as you can see there. Okay, so now that we know our environment a little bit better, let's actually go ahead and run our first job. Before I go through what steps we'll be executing, this is a good time to actually take you through what our MPI Hello World application looks like. So this is just a very simple application, and you'll be able to see that we're actually executing this on the cluster running Slurm. And there may be some variations in your configuration, but I just want to share with you just how generic this process actually is. So let me just go ahead and see if I can get the visual editor up. So basically this is the Hello World application, and just notice that it's quite simple. So basically we'll just be iterating through the nodes, and as soon as we go through each node, we'll just be essentially printing out Hello World as we iterate through the nodes. So let's actually, I'm just going to copy this essentially and just run it in my environment. So we've got it here. So obviously in your case, you know, this is essentially how you'd be doing it on premise as well. But the cool thing is basically you would do it in exactly the same way, but now you're just doing it on the cloud. So pretty cool. Okay, so we can actually then test our application locally on the head node for testing. So you just essentially run MPI run, and let's actually run the application and see if you're able to actually test that out. Yeah, cool. So basically this is the output that you would want to get when you run it essentially on the head node. So that's cool. All right, so our application is actually compiled and it's ready to be executed. So let's build a batch submission script and let's submit it to Flow. So we will, I've got this pre-populated here, so I'm just going to essentially copy and paste this. So we'll create a submission script that will run 4 MPI processes. And it'll generate the output file and send it out. So that's basically what I've just done there. All right, so now let's submit our first job. So I'll just type in my batch submission. So cool, there you go. So I've submitted 2 jobs, so that's good. It's all happening, which is good. Okay, so now let's check the status of the queue. So we'll essentially use the same command again, sq, to be able to see what is there. So you'll notice that it's saying, so I've submitted hello world, their job IDs, there are 2 nodes that it's essentially going to be set up for. And you can actually check out sinfo as well to be able to see if there is anything up and running. So there isn't any nodes up and running yet because it just does take a little bit of time. So it takes generally less than 1 minute to appear. So if we kind of keep refreshing that, would be able to see the nodes come up. But let's actually look at and see what's happening there when we're submitting a job. So if I go here, and essentially just refresh. So note that these 2 compute instances terminated when I had no job scheduled. But if we notice here, because now I have scheduled a job, there are actually 2 compute instances that are pending, and essentially now they're running. So automatically, you know, just like that, as soon as I've been able to schedule the job, the parallel cluster has scaled up the number of clusters, the number of compute nodes to be able to handle the backlog of jobs. And essentially there will be essentially scaled down as well when the job is, you know, has completed. Cool. So let's go back to our Cloud9 environment and launch a new job, actually. So we'll launch another job and we should be able to see it scale back out again. Okay, so now I've submitted 3 jobs, so you will actually really be able to see it scale up and down. But the thing is, just note that we have let it we've identified the minimum and the maximum, so it's actually not going to be able to go past the maximum that we've been able to identify. So if I go back again here, we'll actually notice a few more instances that are slowly coming back up. So this is still initializing, and we'll essentially be able to see a few more pop back up as well. And in the meantime, let me just go back here again and just do sinfo and actually see if there are nodes that are coming up or okay, so you can see that we've had 2 jobs submitted, so essentially it's calling out here the job IDs and of course the nodes. So there you go. So we can see that there are actually more instances coming up that essentially are going to be handling that job. So the more you keep adding jobs to the queue, you'd be able to go essentially to the maximum of 8 is what we've identified, but essentially you can scale it up to maximum of whatever your workload needs, really. Yeah, so that's basically parallel cluster in a nutshell. Now that we've got a better understanding of how parallel cluster operates, you can see that it's actually super easy to get up and running and get it up and running on AWS. And you're essentially working in exactly the same way that you would have been on premise, but the thing is you're not having to gather the compute resources and scale up you know, your compute and your compute cluster to meet the demands of the workload that you need. That's all just handled seamlessly behind you know, behind the curtain for you using parallel cluster on AWS. So for essentially for the next steps from here, you would be setting up the parallel cluster. So all that's really left for you to do after you set it up is that you'll update the configuration file to the type of instances that you want, the configuration file that I showed you earlier. You will set the desired maximum and minimum number of instances, and essentially you are well on your way to installing your application and running the model and benchmarking your application on AWS.
You're able to create parallel cluster with literally just a few commands, and especially it just sets up parallel cluster for you. And you're able to see that basically all the comforts of a traditional HPC environment, you're able to just essentially set that up with a few commands on AWS. But the thing is, it's a little bit cloudier than just setting it up on-prem, because what it is actually doing is that it's auto-scaling in the background. So a cluster can change the number of compute nodes it has essentially on demand. Basically in the morning, say you've got 6 nodes, and your cluster becomes quite large in the afternoon with a bunch of nodes, and then essentially it goes dormant in the evening. And with just the head node and the shared storage hanging in there with no compute resources in the evening at all. So basically this scaling behavior, as we call it, it actually can be triggered explicitly by you, but many of the people actually let the cluster auto-scale based on the job queue. So that is, when you put a lot of work into the queue, the cluster will allocate extra compute nodes, up to a predefined ceiling, as I was showing you in the config file. And when the work is done, the cluster will detect idle nodes and essentially delete them promptly. Because, it's smart, it knows that you have to pay per node hour or per node second, and it just cares too much about you to be able to let you pay for idle resources. So essentially it shuts it all down. So, for day-to-day applications, for your research applications, it's possible to create many clusters quickly. In-house, you probably have one big cluster that stays, the same for years, and it's shared by many people. But on AWS, you may be starting and deleting clusters all the time, and you may be customizing them for the needs of one person or one project. So it's actually common to create one cluster per application, and then also to create one cluster just for production, one cluster for proof of concept work, and it's totally fine if you can't remember what the cluster name is, because you can just do plist and be able to find out all the cluster names. Of course, you just get rid of the clusters when you're not using them anymore. So yeah, it basically, you're the way that you're doing research on AWS, it's basically accelerating the time to science by using the on-demand auto-scaling of the clusters, rather than you having to essentially look after or essentially house those instances or the servers yourself. What we also see a lot of our customers do is they're able to essentially swap out servers as well. So here we see a cluster that pulls in data from S3 and performs a weather simulation on C5 CPU servers, and then gets rid of them and calculates visualizations on T3 GPU servers. How do you do that? Well, you essentially, the config file that I was showing you earlier, you're essentially just updating the config file, and you're telling the cluster, hey, wait 5 seconds, and then just swap it over and give me a different set of instances so I can run different models and different visualizations. So yeah, pretty cool, and basically, hardware refresh done just like that. And I'm getting a little bit of a lag here, but I'll carry on. So essentially in the cloud, clusters are ephemeral, and only data has the permanence. And so when you're doing simulation visualization, and you've completed both of that, be keeping the data in S3 and completely killing the compute cluster. So it may seem trivial, but the thing is, traditionally, people using HPC, have the culture of, holding on to the servers. So essentially, it's not like that anymore on AWS. You're basically just, getting rid of the servers when you don't need them, and you're using the lowest cost storage to be able to keep the data where essentially data has the permanence. And what that really means, again, is that there's essentially no queuing for compute resources. There's no waiting time, there's no idle time. You're essentially getting access to the resources when you need them right on time when you're having to do that research. One of the other things that we see a lot of our customers using and having really great results on also is Ronin. So Ronin is actually a solution that's been built by one of our partners. And it allows universities to simply manage AWS resources that are especially geared towards HPC with a lot of supporting, simplifying, budgeting, tracking, and spend. So all the things that are not so easy to do with the AWS console, it's made super easy using Ronin. University of Adelaide actually used Ronin to provide seamless bioinformatics training resources in minutes. And it really changed the way that the bioinformaticians were collaborating and doing research for the 2-day event that included 152 bioinformaticians and 15 facilitators across the country to come together and collaborate and spin up resources in a space of minutes, which would have taken them months otherwise. So something like Ronin really can get you up and running easily to start to use HPC on AWS. And we've got a lot of partners, as well, as I was mentioning earlier, that have just made, again, building the building blocks that are just easy to get up and running as well. So if you haven't checked out the partners on AWS, I would highly encourage you to do so. And the workload that you've been trying to get up and running on-prem, you may just be surprised that already exists, in the marketplace, in the partner network with AWS. Let's talk a little bit about collaboration. Essentially, science means collaboration. And this is actually a map of scientific collaboration worldwide. But what this really reminds me of, every time I look at it, is the AWS Global Network. And essentially, collaboration has been made so much easier as well in the cloud because more time is actually spent computing the data than moving the data around. A lot of the times, scientific data can be quite siloed and stored in a way that is susceptible to loss. If you're putting it on AWS and essentially on S3, you're able to not only get the durability with the data, but you're able to also use it for collaboration. And that's basically the premise around the public data sets that are available on AWS. So I've got the link there. It's registry.opendata.aws. And you'd be able to find tons of data that has been made publicly available, and essentially because they're stored on S3, so you're able to, with consent, you're able to make those publicly available. And that's essentially one of the motivators that a lot of the problem in the scientific field around storing data that just kind of goes away, and you're able to enhance collaboration and share the analysis and, of course, reproducibility of the research data. And there are a few other programs, actually, that are also making data sharing easy as well. So there's actually no cost to upload data into AWS. And of course, that's because we're committed to making it easy for researchers to use cloud storage, computing, and database services. So the data egress fees are waived for qualified researchers and academic customers, and you're actually also able to get a discount on the total monthly spending on AWS as well. So if you're interested, feel free to reach out to us. When we're talking about reproducibility, and this is something that, again, is close to my heart because I see that, a lot of scientists, they do acknowledge that this is a big problem with science, and many science studies can't actually be reproduced. This graph shows you just, there's essentially a 52%, significant or slight crisis. The thing is, with AWS, you're able to achieve what essentially we call infrastructure as code, and of course we would have spoken about this during this meetup. But essentially, because code is reliable and it's auditable, and humans just aren't. So the thing is, turning what you have code as infrastructure as code, and of course deploying that in AWS. So you're essentially coding it up in JSON or YAML, storing it on S3, and you can essentially, when you're spinning it up, you're able to spin up that environment and essentially get that reproducibility straight away using AWS. So a lot of times, if you're having to set something up on premise, a lot of your configurations, of course, are not matching. But if you're essentially turning all of those into code, all of a sudden you're able to straight away spin that up. I want to talk to you a little bit about machine learning, because essentially there's a broad and deep set of capabilities in machine learning that a lot of our researchers are starting to find useful, because there are machine learning frameworks and infrastructure for expert machine learning practitioners. So you're essentially able to leverage a lot of those frameworks on AWS. But for everyday developers and data scientists, of course, we've built and launched SageMaker. So it's a managed service that's there to build, train, and deploy machine learning models quickly. And then, of course, for developers with no prior machine learning experience, you can actually just get started to build very sophisticated AI-driven applications. So contact centers, media subtitling, understanding voice. So there's also comprehend, medical comprehend as well for sentiment analysis of medical data that you can basically use to get up and running very quickly. But of course, tying all of this together is security, because research data needs to be secure, and AWS of course provides one of the best security building blocks in the cloud. Because we're constantly adding capabilities to this as well. So you can find infrastructure security, encryption options, and more and more sort of fine-grained identity and access management controls. But I guess some of the ones to really call out is essentially the IRAP assessment that's been done across 92 services, as I was mentioning just before. Yesterday, and I'm pretty excited to say this because I know that Brian didn't have it in his top 5 or top 10, maybe it was. But essentially, yesterday we released a publication of reference architectures for ISM protected workloads in AWS Cloud. So you're actually able to, from AWS Artifact, get the documentation package that shows you, what architectures would look like to get ISM protected workloads up and running, and a lot of that will actually work well with the HPC environments as well. So if you haven't already, please do check that out. And of course, securing data using Macy, that's something a lot of our health customers are looking into, because of course it's able to identify personally identifiable information or intellectual property as well, and gives you dashboards and alerts that you can get visibility into the data and how it's been accessed and how it's been moved. So that's basically everything that I wanted to cover, but there are a bunch of programs there that's there to support researchers. So Cloud Credits for Research is one. We've spoken a little bit about Global Data Egress Waiver Program, and of course Open Data on AWS. If there are other ways that you'd like for us to support you, or if there are other ways that you're wanting to use AWS or you are using AWS, please reach out to us, because we'd just love to know more about that. I guess in the spirit of reproducibility and knowledge sharing, there is a lab, so if you have a spare hour or two, and this is a fun lab that you can actually work through, where you set up a real DNA sequencing pipeline. And this lab just brings together all of the components that we've been discussing here. You'll create a Docker container for each step. You'll use AWS Batch service to execute those containers. You'll use a workflow called using AWS step functions, and it also uses data sets from the Open Written Data Registry on AWS. So that's everything that I had for us today. I'm going to go back and have a look at the chat, but I'll hand over to you, Brian, because I'm experiencing a little bit of lag.
No, that's fine. Thank you so much for that presentation, Raisa. I'm sure everybody found it interesting. There was a little bit of chat there about whether or not you'd SSH from your Mac through. But other than that, I think we're all good. So again, thank you for presenting for us, and thank you everyone on the stream for watching this session. Hopefully you got something out of it. If you've got any questions, feel free to drop them into the chat on Twitch, or if you're watching this on YouTube at some point in the future, because we've got a YouTube channel now. Remember that one. Feel free to drop comments on the videos. We'll do our best to keep an eye on those and answer questions as they come through. But otherwise, thank you for spending your time with us this evening, everyone. And we'll be back again next month with more AWS goodness from the nation's capital. But otherwise, thank you again, and have a good night, everyone.